2.1 Radian Measure. We have been working with angles measured in degrees, but in more theoretical work in mathematics, radian measure of angles is preferred. Radian measure enables us to treat the trigonometric functions as functions with domains of real numbers rather than angles measured in degrees. So radian, an angle with its vertex still at the center of a circle with an intercepted arc on the circle, is equal to the length of the radius of the circle. We would call this 1 radian. So imagine this straight line segment R. We were able to pick it up, attach it here, and bend it along the curve of the circle. That becomes our new 1 radian measure for theta. And we can go all the way around the circle like that. So here is an example of 2 radians on that intercepted arc. We just took the radius and bent that line segment and curved it. Here is half a radian. You should know, come back here. You should know the formula of the circumference of a circle is 2 pi r. And that's 1, 2, 3, 4, 5, 6. And there's a little section there. Now, if you think about 2 pi, pi by itself is from 0 to 180. And pi is approximately 3.14. So that decimal version is that short little segment of the arc right there. If we double pi to 2 pi, that's 6.28. Now the 0.28 represents this little short arc on our circle. So in general, now that your radius is a 1, your theta will always equal the arc length divided by r. And if r is a 1, then it's just the arc length. So theta is always measured in radians. It's going to be the arc length divided by the radius that will give you your approximation of your radians. So again, theta, the number of radians, equals the arc length s over the radius r. So if we had to approximate below to whole radians, I'm looking at this as being 2 radians. Now be careful, it looks like 1 radian, but again, we're going in the opposite direction, so that's considered negative 1 radians. This would be 3 radians because there's that little 0.14 left over. So what we're going to have to be able to do is convert between degrees and radians. So the circumference of a circle, 2 pi, all right, 360 degrees, they're equal to each other. So we're going to simplify that down to 180 degrees is equal to pi radians. So if you are going to take a degree and convert it into radians, you want to multiply it by pi over 180 because now the degree units will cancel. And vice versa, if you're in radian, you want to put the pi symbol in the denominator and divide by pi into 180, or most of the time these radians will have a pi symbol in it, so we cancel the pi's, multiply together, and we have our degrees. So again, some people will say multiply a degree by pi over 180 radians and simplify to convert to radians. Multiply a radian measure by 180 degrees over pi and simplify to convert to degrees. So let's look at some examples here. Converting 45 degrees to radians, multiplied by pi over 180. Again, I want the degrees to cancel. And 45 goes into 180 4 times, so this is pi over 4 radians. Negative 270 degrees, multiply by that same converting fraction. Degrees cancel, and let's see, 180 and 270 are both divisible by 90. So this is negative 3, this is a 2, so we end up with negative 3 pi negative 3 pi over 2. If we come across an ugly decimal like this, still multiply by pi over 180, but we're not going to attempt to simplify this crazy decimal with our 180. We're going to let the calculator do all the work. So I would type it in as 249.8 divided by 180. Notice that the pi symbol is not part of my calculator entry. All I'm doing is simplifying this fraction. Now, to find this command, you hit the math button, and it's already highlighted option 1, so just hit enter again, and here's my answer. So that simplified radian is 1,249 over 900 times pi, or you can put the pi up in the numerator. If we want to take 9/4 pi and convert it to degrees, now we put the pi up by the 9 and we want to get that pi symbol to cancel, so we multiply by 180 over pi. The pi symbols cancel, and then we can start to reduce. Now, before we do that, a shortcut for this is because pi equals 180 degrees, whenever you convert to degrees, you can just find the pi symbol and substitute in 180, and this is where we're at. It's good to remember this ratio because if you notice, sometimes they don't give us the pi symbol and we're going to need to use it. So 4 goes into 180 45 times, so that's 45 degrees times 9, 405 degrees. -5 pi over 6 times 180 over pi, the pi symbols cancel. 6 goes into 180, 30 degrees, times -5, -150 degrees. For part C, 4.25, multiply that by 180 over pi. Now there's no pi here, so I'm going to enter it as such. 4.25 times 180 divided by pi. 243.5070629. Rounded to 3 decimal places. Now, I'm going to stop here for a quick note. If the directions tell you to use the pi symbol, then use the pi symbol. But if they tell you to use 3.14 instead of the pi symbol, now you really want to follow the directions. I'm going to bring up my calculator here and show you why. So if I type in, let me clear out all those buttons down there so that doesn't confuse you. If I type in 4.25 times, whoops, not times, or dividement to times, 180, but now I divide by 3.14 because that's what the directions told me to do. Notice that there's a difference in my degrees in the first and second decimal place value. 5076305. So that would be a different answer. So gotta be careful, follow the directions, because if you do this and they tell you to 3.14, it will be marked wrong because the calculator, or excuse me, my math lab will look for 243.631 degrees. So make sure we pay close attention to those directions. All right, now again, make sure you understand, am I working in degrees or am I working in radians? For example, here's a 30-degree angle, here's 30 radians. Almost gets around 5 times. So we got to be careful here. So the one thing I'm going to be working on is looking at degrees of our special right triangles, the 30, 60, 90, 45, 90, and we're going to look at their exact radian measures. So 0 degrees is 0. I'm not worried about the approximate value because you can always go to your calculator to find that. 30 degrees is pi over 6. That's because the 180 divided by 30 is 6. There's your denominator. 45 goes into 180 4 times, so that's pi over 4. 60 goes into 180 3 times, so there's my denominator, pi over 3. 90 goes into 180 twice, that's pi over 2. Like we said, 180 is pi, 270 is 3 pi over 2, 360 2 pi. So to practice this, I'm going to show you some couple different techniques on how to do this. Put in your 0 degrees, and some people you can put in your 90, 180, 270, back to 360 if you want. But then what we're going to do is what I like to do. Don't even have to put in the 90, 180, 270 yet. Just go straight across to 180 and count how many sections coming back, because they look like they're all equal size. 1, 2, 3, 4. So 180 divided by 4 is 45, and now you just count by 45 all the way around the circle. So 45 plus 45 is 90, plus 45 is 135, plus 45 is 180, plus another 45 is 225, plus 45 to 270, 270 plus 45, 315. So these are the locations, if you will, of our 45, 45, 90 right triangle on our unit circle. All right, over here, put in your 0. Oh, check that. I forgot. We got to do our radians. So 0, again, there was 4 equal sections, so pi divided by 4 will be pi over 4. Count by pi over 4. That's 2 pi over 4 reduced to pi over 2. 3 pi over 4. 4 pi over 4, which reduces to pi. 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. And 7 pi over 4. Again, if you want to put in the 360 and the 2 pi, you're more than welcome to. All right, now to my other circle, which represents the 30, 60, 90. Again, if you want to put in all the quadrants, you can, but again, you don't have to. You can build this as you go. So 0 to 360, there's my pi. 1, 2, 3, 4, 5, 6. 180 divided by 6 is 30. So all these lines are counting by 30. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, back to 360. So as I said, you don't have to put the 90, 180, 270 in right away. You can just build it and find them. So again, there's 6 equal pieces. Pi divided by 6, pi over 6. So we're counting by pi over 6. This would be 2 pi over 6, which simplifies to pi over 3. 3 pi over 6 simplifies to pi over 2. 4 pi over 6. That reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which will reduce to 4 pi over 3. 9 pi over 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. There's my 11 pi over 6. And of course, 12 pi over 6 would simplify to be 2 pi. All right, one more quick challenge. Don't look at the center, you'll get dizzy. All right, starting at 0 radians, fill this all in. So again, straight across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm counting by 12s. Now, we could do the same thing as we did earlier. This would be 2 pi over 12, which is pi over 6. But let me show you a nice shortcut with your calculator. If you're going to count by the same value over and over and over again, okay, there we go. What we can do is we can build a table. So, second graph gives you a table. Second window tells us how to start the table. So let's go to y equals, clear that out. Don't need it, that was for a different class. And let's build our fraction. So alpha y equals, give us a fraction. We want 12 in the denominator because that's always the same. And what we're changing is the numerator because we constantly count by 1. So we'll call it x over 12. I'm going to enter that. Now I'm going to go to my table setup, second window. Whoops, I want to start at 0. That was my 0 radians. Enter. And now the cursor is where do you want or how much do you want your table to count by? That little triangle is the change in your table. So I want it to count by ones. Make sure the autos are always highlighted. Now hit second graph. Wait a minute. Wait, I think I changed my mode. Yep, I'm in decimal mode. Let me go back here to auto. Sometimes you got to fix your calculators here. Those should have all came up to be fractions. Let me go back to what, because we used the fraction command there. Let's try this again. Second. Boom, there we go. Second graph. There's my 0, my 1/12. So all we have to do is put pi on the top with the numerator. 1/6, 1/4, 1/3. And you can just keep scrolling down and you'll find all the fractions until you get to 24 or 2. There's my 2 pi. So that's a quick and fancy way to get to all those fractional radians going around the circle. Just take all those fractions from the y column and put a pi in the numerator. And we are good. All right. So that wraps up